All right, so let's talk about factoring binomials. When we want to factor binomials, we have to remember a little bit about the distributive property. So the distributive property was you were distributing out a 3 into these parentheses. And we had to simplify it because we can't combine these. These are like terms. So the one way that we could distribute is through the distributive property. And we distributed that 3 times to each of the terms inside. We have an x and a 2. So that's simplified to 3x plus 6. And distributing is multiplying. We have to remember now that factoring is its inverse. It's dividing. So when we see a binomial like this, we want to factor. We want to take out a common factor. One of the ways that we do that, is we take the prime factorization of each of the terms. Prime factorization of 3x is 3 times x. The prime factorization of 6 is 2 times 3. And then we look for the greatest common factor. So they have a 3 in common, so my GCF is 3. So I'm going to take out a 3 from both of those terms. If we take a 3 out from 3x, if we take this 3 out, we're left with x. If we take this 3 from 6, we're left with 2. So a nice way of factoring 3x plus 6, this is our greatest common factor, and we took that 3 from 3x and 6. Another way of looking at it is we can write 3x as 3 times x and 6 as 3 times 2. And we'll take out that GCF of 3. We see they both have a common factor of 3. If we pull that out, we notice that we're left with x plus 2. So it's a reverse of distribution. If we went this way, it would look like just distribution, distributing that 3 to both of the terms. If we go the other direction, it's called factoring. So the technique and the best way to go about doing this is, I feel, is you take the prime factorization of both of the terms. 4x is 2 times x. 22 is 2 times 11. And we want to circle what they have in common. So they have in common a 2, so my GCF is going to be 2. And after I take that out, what am I left with? I'm left with 2x and 11. So that now becomes 2x plus 11. So if we were going to factor 4x plus 22, take the greatest common factor from it, you would be left with 2 times the quantity, 2x plus 11. That's the distributive. All right, so let's look at this example. We have 32x and we have 20. 32 is 2 times 2 times 2 times x. 20 is 2 times 2 times 5. What do they have in common? They have a 2. They have another 2 in common. So their GCF is 4. When I take that 4 out, I'm left with 8x plus 5. 8x plus 5. This is a positive 5. That's why that sign is positive. This sign is not positive because of this. There will be situations where these two signs will not be the same. So that just depends on the situation. And we always want to make sure that we take out the greatest common factor. So if we look at that problem, 32x, plus 20, if we took out just a 2 and factor out a 2, we'd get 16x plus 10. And what's wrong with this is it's not simplified. It's not completely simplified or factored. And it's not completely factored because there's still a common factor within these two terms. You can still factor out a 2. That's why we always have to take the greatest common factor. Let's take a look at this one. 28y, that would be 2 times 2 times 7 times y. 42 is going to be 2 times 3 times 7. What do they have in common? They have a 2 in common. They have a 7 in common. So my GCF is going to be 14. I factor out that 14, and I'm left with 2y plus 3. And I'm getting that 2y from this, and I'm getting the 3 from this after I take that 14 out. And the 14 is represented as 2 times 7. This is a good one because we have a variable. We're now introducing variables, so the prime factorization is going to be 2 times 3 times 5 times x. We just break that. Prime factorization of variables are actually really easy. And then 50x would be 2 times 5 times 5 times x. What do they have in common? They have a 2 in common. They have a 5 in common, and they have an x in common. So this time, my greatest common factor is going to be 10x. So I'll factor out that 10x. I'm left with 3x plus 5. And again, I got the 3x from here, and I got the 5 from there. So really nice, efficient. Here's our next one with one of our terms is negative this time. So that's a little bit different. So we're still going to go through the same process. We just have to respect that that negative is attached to the 40. So the prime factorization of 12x is 2 times 2 times 3 times x, negative 40. And the way we represent that negative is we give it a negative 1. And then we take the prime factorization of 40, which is 2 times 2 times 2 times 5, I think it is. Now, what do they have in common? They have a 2 in common. They have another 2 in common, and that's it. So my GCF is going to be 4. And then what am I left with? I'm left with 3x. And then I'm left with negative 1, 2, and 5, which gives me negative 10. So we still have to hold on to that negative sign. And whenever we have our answer, we should always be looking and making sure that we took the GCF. Make sure that there's no common factors left in there. And if we go back to that one where we didn't take the greatest common factor, we see that there's still a common factor of 2 in that problem. So that's what we always are looking to see. Hey, is there still anything left in there that I can factor out? And there isn't, so I know that my answer is correct. This is another good one. This problem, we're going to do prime factorization of 36x, which is 2 times 2 times 3 times 3 times x. Prime factorization of 6 is 2 and 3. We circle what they have in common, and they have a GCF of 6. And finding out what's left after factoring a 6 out of 36x is relatively easy. That leaves me with a 6x. However, when I take out a 6 from 6, notice there's nothing left here. There's nothing in here. Well, we need to remember that factoring is division, and 6 divided by 6 is 1. So we have to represent that place by putting a 1 in there. And that makes sense because if we redistribute it back out, we would get that 6. So that's why it needs a placeholder. So that one's tricky. Be careful of that one. Our other tricky one is when our first term is negative. We can never have a first term. Well, whenever we're factoring, we don't want to have a first term negative. So what we want to do is we want to factor out a negative. So we must factor out a negative. And that's easy when we look at negative 9x because we have negative 1 times 3 times 3 times x. However, we have to factor out a negative from 30. Well, there is no negative there. 30 is a positive number. So remember, I need to factor out a negative from this. One of the common has to be a -1. So how can I keep 30 positive, but I have a negative here? Well, the trick is you multiply them by 2 negatives, and then you factor the 30, which is 2 times 3 times 5. So now when we look for the common factors, we remember we have to factor out a negative. They also have a 3 in common, and that's it. So the GCF is going to be -3. And now what's left is we have 3x minus 10. And now our first term inside the parentheses is positive. So we have done well. We satisfied that situation. So, and notice that our signs change this time. And that's that one time where they will change and be opposite. All right, so that's pretty much the hardest one that you might have to figure out. And before we go, let's try this one. So pause the video, try to do this one by yourself. And when you're ready, push play and we'll go over the answer. So the first thing you want to do is you want to find the prime factorization of 18x, which is 2 times 3 times 3 times x, and the prime factorization of -12, which is -1 times 2 times 2 times 3. Circle what they have in common. We don't have to introduce an extra negative because my first term is positive, so we don't have to do that trick. And then we have that, so my GCF is going to be 6, and then my leftovers are 3x minus 2. So I just factored 18x minus 12 to become 6 times the quantity 3x minus 2. All right, good luck.